it's amazing. But actually, not as fast as Emilio, who types really, really fast. So I want to actually share with you a great puzzle, a great riddle, that's going to be solved two different ways. The way they want us to solve it, and then a special way just for you and me. Love some fun. Here we go. So Emilio types at a rate of 84 words per minute. So that's a little bit of a ratio right there. 84 words per 1 minute. That's what that means. Now he claims that he can type a 500-word essay in 5 minutes. The question is, what do we think about Emilio's claim? And how can we use a graph to help explain the answer? Well, first of all, let me just show you a really simple way of actually figuring out the reality. And then we'll use the graph, since that seems to be what people want us to do. But let me just say, 500-word essay in 5 minutes. Let's make a very quick ratio of that. 500-word essay, so 500-word essay, 500-word essay, and I'm going to say 500-word essay is to 5 minutes. So now if I want to see what 1 minute would be, what do? Well, you know how to write an equivalent ratio. All you would do is either multiply or divide by the same number on the top and the bottom. Well, in this case, I'm going to divide the top and the bottom by a number that's going to make this 1 minute. So what do I have to divide 5 by to make it 1? Well, the answer is just 5, of course, and then 5 on top. Now check this out. 500 divided by 5, you know what that is. That's 100 words. And 5 minutes divided by 5 is 1 minute. So in fact, if he claimed that if he really could type a 500-word essay in 5 minutes, that means that he'd be equivalently typing at a rate of 100 words per 1 minute, or 100 words a minute. But we're told that he's only typing at a rate of 84 words per minute. So in fact, we know that actually Emilio's claim is not quite right, because in fact, he'd be claiming to be typing faster than he actually can. Wasn't that easy? But that is not what they had in mind for us, because they want us to have some fun with the graph. So we're going to do it a totally different way, but this is the way I would do it. And the way we're going to do it now is by looking at a graph. So we're going to do the exact same process, but we're going to look for a pattern. So we start with the fact that we know he types 84 words in 1 minute, so there's the ratio. So if I multiply that by, let's say, 2, that will give me an equivalent ratio, and it will tell me how many words he types in 2 minutes. And so what I see here now is that this ratio, 84 words per 1 minute, will equal 84 words times 2 over 1 minute times 2, which will equal 168 words per 2 minutes. So that's his rate for 2 minutes. Then how would I find his rate for 3 minutes? Not a problem. If you want to know his 3-minute rate, all you've got to do is now multiply the numerator and denominator, top and bottom, by 3. And that will give you the 3-minute rate, which is 252 words per 3 minutes. If you want to get the 4-minute rate, you multiply the top and bottom by 4. Isn't this fun?
See this pattern?
Very fun. And you get 336 words per 4 minutes. Multiply by 5 on the top and the bottom to make sure we're having an equivalent ratio. And you're going to get 420 words per 5 minutes. And if you did multiply top and bottom by 6, that would tell you that multiply top and bottom by 6, so it's equivalent to the original one. We get a ratio of 504 words per 6 minutes. Now, what can we do with all of these things? Well, I could actually list the words and the amount of time that it would take Emilio to type that many words. And if we made a little table...
Hey, do you have any questions so far? Anything out of the ordinary? Anything you've never seen before?
Wait, so reference space had 84?
It's a different problem from the first one. You're talking the 500 words?
Yeah.
That was a different problem.
Okay.
So this now says you can type 84 words per minute, not the 100 words per minute. Different set of numbers, same process.
Like the number of words are like the graphs all different pieces. Like on the side, like how those.
That's a good question. Typically on the left side of your graph, the y-axis, the one that goes up and down, That's going to change to, whatever we're looking at. Almost every single graph that I can think of that uses time has time across the bottom on the x-axis. Anybody know why?
Because they're just smaller numbers.
Well, when you get into the higher grades, when you get a little older, you'll talk about independent variables and dependent variables. Time is always an independent variable. It doesn't rely on other things to move forward. Time doesn't stop. Time doesn't slow down. Time doesn't change. It is always moving at a consistent rate. So across the bottom there, time in minutes, it's always going to be the same thing. It's never going to be a smaller amount in between each one. You're never going to have weird numbers for time. It's always nice and equal. Time does not rely on anything else. Now, in this particular circumstance, and you guys don't really need to know about independent and dependent variables just yet, but the independent variable is time. The dependent variable, number of words. Dependent just simply means it depends on how much time has passed. So if 2 minutes have passed, the amount of words that this person was able to type is dependent on that time. 84 words for every minute, and if what's his name, Emilio types for 2 minutes, that number is dependent on the amount of time that has passed. So now we're going to get into, well, what do we do with this information? 84 words per minute. You can actually take these things and pair them in an ordered pair. Now, you have done graphing in the past, correct? So you know what an ordered pair is. In parentheses, first number, comma, second number. Which one's the x? The first number. The first number is always the x. We always list x first, x comma y. And then when we graph it, he'll show you.
It would look something like this. Isn't this much easier than the way that I first showed you? Well, maybe not. But it's actually very important because we can learn things. Check it out. 84, 1 minute. 168 words in 2 minutes. 252 words in 3 minutes. 336 words in 4 minutes. 420 words in 5 minutes. And 504 words in 6 minutes. Okay. Now we could actually graph it. Now graphing is kind of fun because we get these a coordinate plane, and that is kind of fun actually. So let's have some fun. Let's just graph these points. And notice I'm going to put the time as the x and the number of words as the y. So this is the x and this is the y. In fact, maybe to make it easier, I'll even write in here x and y, and that will help us to make sure we don't make a mistake. So the first ordered pair is 1, 84. 1, 84, that's a dot right there. The next one is 2, and then 168, so 2, 168. The next one is 3, 252. What? And 9. 3 is going to be, I just did that one, so 4 is going to be 336. 4, 336. And then 5 is going to be 420. And then 6 is going to be 504. Kind of interesting how they all kind of live on what looks like a kind of a line. Isn't that kind of neat? That, by the way, is a property that we'll see again and again with ratios that are equivalent. In fact, they all kind of will lie on that kind of thing. So, but anyway, the bottom line is, what do we think about Emilio's claim? Well, let's think about it. He said that in 5 minutes, he could type a 500-word essay. But we've already figured out that in 5 minutes he can only type 420 words.
Oh,
so
that's
therefore
where
we
that
know
question
the claim is not quite right, and we can see it on the picture by looking at 5 minutes and seeing that he's actually at 420 words and not at 500. In fact, if we gave him an entire extra minute, so he typed for 6 minutes, he's only going to type 4 words over 500 words.
So, I missed that first part. Emilio claimed that he could type a 500-word essay in 5 minutes. So, does it sound like he was over-exaggerating?
Yeah.
Does it sound like somebody we know?
Yes.
Yeah. I think he can do it. Let's go.
Mathematically, he can't do it. We just proved that he could not do it. Numbers don't lie, Max. Numbers don't lie. Numbers don't lie. Hey, let's finish the video. Numbers don't
What
lie.
if you could
Numbers don't lie.
just tap one button forever?
Let's finish the video.
What if you just kept holding down one button?
One button's not a word. Finish video.
So really, 5 minutes is not enough time for Emilio, at his rate of typing 84 words per minute, to actually produce a 500-word essay in 5 minutes. So there's a visual way of doing it where we see lots and lots and lots of numbers. I showed you a kind of a faster way of doing it too, which I think is nice as well. Both have wonderful, wonderful, interesting applications and utility. You can pick what you like, but the important thing is to really understand what does it mean to have an equivalent ratio. Equivalent ratios are found, and now it's time for me to type and tell my friends about our adventure together. So I'm going to send an email. We just had so much fun thinking about equivalent ratios. Send. Have fun with math. I'll see you soon.
Okay.
Dr. Bird.
All right. Let's take a look at what's going on in your book. Everybody see that okay? I know you guys here in the back of the room probably, yeah, you got your books in front of you. All right, so we are on page 255. Let's take a look. Let's do a problem together. Car travels at a rate of 50 miles per hour. Use equivalent ratios to graph the distance that the car travels over time. Graph time on the x-axis and distance on the y-axis. What words in the problem tell us the unit rate? Right?
50 miles per hour.
50 miles per hour. That per tells me that that's going to be my division bar. Does it say how many hours?
No, just says per hour.
How many are we talking about?
1?
1. Because I don't walk around and say I have $5 in my pocket.
Yeah.
I have $5. Or $5.00. Sometimes we drop that stuff, but we just assume that it's still there. All right, so 50 miles per hour. The unit rate, hey, we just wrote that. 50 miles per 1 hour. So if we write the 50 miles here and we double both things, multiply the top and the bottom, because if we multiply the numerator by a number, we have to multiply the,
Bottom.
Bottom.
So
Top.
yeah, it's bottom, but can we say it like 6th graders?
Denominator.
Denominator, thank you.
Ollie.
50 times 2 is,
100.
1 times 2 is,
Ooh.
do you want to do that a bunch of times, or can we just do the chart?
He didn't do that.
Let's just do the chart. So in 1 hour goes 50 miles. In 2 hours goes 100 miles. In 3 hours, 150. Oh, that's a missing number. I'll bet you this one's 4. How many in 5 hours? 250. You're just counting by 50s there. Now, when you have this chart all done and filled out, you can actually take those numbers and group them in ordered pairs. Time is going to be your x value. Distance is your y. So 1 comma 50. 2 comma 100. And what comma 150? What comma 200?
4.
And 5 comma
250.
250. So, a long time ago, back when I was in school, my teacher stressed to me that anytime we're talking about ordered pairs, you have to say the comma. It sounds silly. Yeah, 1 comma 2. But if you say the word comma in your mind, you're like, oh yeah, I'm working with ordered pairs. I got to do some graphing. So, we weren't allowed to leave class until we said comma.
Cardinal.
Not caramel, comma. All right, I'm going to move this down, but that's going to throw off all my numbers. You have it written in your books. Then it says, use those ordered pairs to graph distance over time. So x values first. That's across the bottom. I'm going to make this bigger. There we go. That is gigante. Okay. So when we do our graph, hey, look, they already did one for us. 1, 50. In 2 hours, how far does a car go? 2, 100. Next ordered pair would be what? No, we already did 150. You don't say 150. You say 1, 50. We already did that one. 1, 50. It's already marked.
30,
Is that what we wrote down?
It's just a line.
Okay, caution. It's not a line. It looks like a line. Once we get all these points drawn in, it looks like a line, but it's not a line until what? Until when? Until we connect them. He didn't say anything about us connecting them. And Professor Berger in the video we saw, he said it looks like a line. It looks like it's going on that diagonal. But we haven't connected it yet. And we'll talk about that later. But if we connected them, yes, it would be a line. Done. Next, turn the page. Whoa, gotta zoom out a little bit.
Yeah.
During a heavy rainstorm, the waters of the Blue River rose at a steady rate of 8 for 8 hours. The graph shows the river's increase in height over time. Use the graph to complete the table of equivalent ratios. How many inches did the river rise in 8 hours? So what's the point? Why are we doing this stuff? On the graph, x-coordinates represent time in what? What are we measuring time in?
The x-axis.
time in an
Or the
hour.
x-axis in hours.
We're measuring time in hours. You can see that clearly here with the HR. What are we measuring height in?
Inches.
Yeah, inches. The ordered pair 1, blank, 1, 3 means that after 1 hour, how many inches of rain have fallen? Yeah. So if I were to read this graph, I see that in 1 hour, 3 inches of rain have fallen. 2 hours, how many inches of rain?
6. Multiplying.
What number goes here?
9.
12. Not 9.
Skipped it.
Ah, see, you were looking for a pattern.
Uh-huh.
We've been doing that. Here, you can't look for a pattern. You actually have to see what it says.
The numbers.
It does not say 9 because there's no dot there. After 4 hours, Sean,
It's 12.
it's 12. Nice catch. He was taking this and just multiplying it by 3. What number goes here? Oh, wait a second before I do that. See, it's a 6. 18. Look at my graph. After 6 hours, 18 inches of rain have fallen. And after 8 hours, 24 inches of rain. Or no, I'm sorry. The river rose 24 inches. 24 inches of rain in 8 hours is a torrential flood. Yeah, that's in 8 hours' time. That's this much rain. That would be devastating. I don't.
That's the draft. That's the trade.
Do you see a pattern in that table? Roger, what do you think? Do you see a pattern? I'm here at question number 1. What's this do?
1. Look for a pattern. Describe the pattern you see in the graph and the table.
Oh, okay. If I hit that button, it reads it to us.
Yay.
Roger, describe the pattern you see in the graph and the table. Goes by 3s? Ellie, help him out.
It goes by 2s.
Goes by 2s?
At the bottom it does 2 plus 8. And then
Okay, alright. So we goes by 2s? What's a better way of saying that?
I was going to say every hour 3 inches of rain.
Every hour, 3 inches of rain.
one.
Let's go back to her goes up by 2s. David. No, hold on 1 second. Brenna?
Add 2.
Not add 2.
Double.
Double! What's 1 doubled? What's 2 doubled?
4.
What's... Oh, wait a minute.
No.
Where's that 2 is 8?
That's why I said add 2.
You double 3.
What?
No.
For every 1 per hour, that's 3.
Didn't you say that? I don't think we can find a pattern as easy as it doubles or it... I think we got to go with what Michaela and Max said. Every 1 hour, we get 3 inches of river rise. 2, 6, 3, 9, 4, 5. Wait a second. You see a pattern there?
Yeah.
Did somebody say multiply by
3.
3 earlier? You're looking at. Explain how you know that the ratios are in the table are equivalent. Are they equivalent?
Yeah.
Yeah, they just keep skipping.
They are equivalent.
How do you know they're equivalent?
They're just skipping numbers.
Well, there's a better way of saying skipping numbers. Three's not even. Allison?
That you have to multiply.
Whatever I did to this number, I also did to this number when we filled in our chart. So if I multiplied by 2 here, I multiplied by 2 here. If I multiplied by 4 here, I multiplied by 4 here. Our unit rate, 3 inches for every 1 hour, did not change for what we multiplied it by. Number 3 there. Mattern's $12 per hour. That's a good paying job. Explain how you would use equivalent ratios to draw a graph of his earnings over time. Well, you just do, you do that.
$12 per hour.
So how much did he make in 2 hours, Harley? You know why I called on you? Because I saw you staring off into space. If he makes $12 per hour, how much does he make in 2 hours? 24. How much does he make in 3 hours?
36.
36. How much does he make in 5 hours? Ah, see, I tried to trick you there. I skipped the 48. All right, let's go on. Hey! Oh, this one says on your own, so I'm not going to help you.
Oh
No, we got to do the share and show first. A redwood tree grew at a rate of 4 feet per year. Use this information for questions 1 through 3. Let's work on this at our seats here. Let's do this problem. Complete the table of equivalent ratios for the first 5 years. I'll help you get started. Ready?
no.
Okay, go.
Yay!
want you to do the graph.
Well, like, you have to label it on your own.
Oh my gosh! You have to label the graph all on your own? Whatever will we do? Hey, in technology class, because I have you in for we had to make our own labels, didn't we? Yes. Yes, I want you to do the graph. Yes, I want you to make up your own labels.
Marketing goes.
Okay, I think most people have gotten the chart and the ordered pairs figured out. After the first year, how many feet did the redwood tree grow? Lindsay? 4, not 5. So if I double the number of years to 2, what happens to the height? Eric?
8.
How's it 4?
Just
Let's complete the table.
Yeah.
For the first 5 years, years are time. Now, thank you for making that mistake, because that shows us that it's actually common. A couple of people in class made that. You have to make sure you're able to pick out the information that they're giving you. A redwood tree grew at a rate of 4 feet per year. Complete the table for the first 5 years. So years are time, they go on the bottom. The other thing is what goes up on top. 1 year it grows 4 feet, 2 years it grows 8 feet, 3 years it grows 4, 8, 12, 16, 20. Now, that pattern works nice and pretty because we went up by the same thing each time. But if I went 1, 2, 4, oh, what would 6 be? 24. So my ordered pairs, 1, 4, 2, 8, 3, 12, 4, and 16, 5, 20. Hey, my technology ladies, how do I graph this? Go ahead. No. I gotta put labels on here, don't I?
Yeah.
Okay, so what goes across the bottom?
1, 2, 3, 4, 5.
Yeah, these are nice, pretty numbers. 1, 2, 3, 4, 5. Time in years.
But don't you gotta go all the way across?
You want to go all the way across? 6, 7, 8. How about height in feet?
Then you would do 4.
It won't be enough. Because that's 2 columns.
So I just keep going.
Wait a minute. You see how this is a nice, pretty pattern? Could we just count by 4s?
Yeah.
4. By the way, this point right here, does anybody know what this is called?
0.
Oh.
It's the origin.
Yeah.
It's 0, 0, 0, 0. 4, 8, 12, 16, 20, 24.
28.
32.
Okay. Hey, these little arrows here tell me that goes on forever. Up and to the right. So, after 1 year, we're at 4 feet. After 2 years, we're at 8 feet. After 3 years, we're at 12 feet. After 4 years, we're at 16 feet. After 5 years, we're at 20 feet. Not a line, but it follows that nice pattern. How tall will the redwood be after 6 years? After 8 years. 32. There's no dot there. But if I follow that same pattern, how tall will it be after 3.5 years? I don't know about 12.5.
14.
It'll be 14. 14 feet. 1 1 year, it grows 4 feet, which means in half a year, it grows 2 feet. So we're going to take our 3 foot, which is 12, we're going to add 2 feet, 14. Hey, I have good news,
And bad news.
and I have 2 bad newses.
Complete your homework.
First bad news, you have homework.
Exactly.
The good news, we're done with the lesson. The other bad news, that's the last lesson of this chapter.
No.
Which means, ... we will have a test coming up. Oh, that's right, we don't call it a test, we call it an in-class homework assignment. Because tests ain't no thing. Yeah, we don't even know what tests are. There's no such thing as a math test. In-class homework assignment.
It's just practice.
So, here's what I want you to do. Flip the page.
Oh, I don't know.
On page 259. Whoa. What's with all the groans?
It's all one.
It's not homework, though. It's not difficult. On page 259, I would like you to do 1 through 7. The reason we're doing number 1, it's not fully completed. Oh no, I'm sorry, it is. Number 1 is make the chart. Number 2 is what are the ordered pairs. Number 3 is make the graph. 4, charts.